Assalamualaikum, my name is Afiq Hatta, representing my group 5, together with Syed Abra, Nurul Shahada, Haikal Jamali and Aiman Fikri. So in this video, I will explain and compare the result from the simulation and the result that we obtained from the experiment. So this is the simulation model. So we use the simplest technique, which is V over F control, just an open loop scalar control. And then to compare the simulation result with the experiment result, so we represent the motor by using this R load, since the motor is not connected to any load and the motor is free running, which is no load connected to the motor. So for low, we need to analyze for three different speed: low speed, medium speed and high speed. So here we start with the low speed. For low speed, we set the fundamental component to 10 volt. Okay, here we set to 10 volt. Okay, and since VDC we set to 75 volt, and then the V maximum we will get VDC over square root of 3, 43.3013. And then for low speed, we need to set the appropriate stop time here for three cycles only. So after we have set the appropriate stop time, and then we just click run and wait until the simulation is finish run, and then we will observe the frequency spectrum of the output voltage. Okay, once it is done, we click to this block, power GUI block, go to tools tab, and then we choose FFT analysis. So here for the fundamental frequency, we need to set for the appropriate value. So for low speed, we need to times 10 volt times the ratio 50 over 43.3013, which is the gain here, and then we just click display to see the result. Okay, now here is the 9.993, where we set the fundamental component is almost just now we set 10, so 9.993 is almost 10. And then this value 11.547 is when the fundamental component 10 volt with times with the ratio V over F 50 over 43.3013, and then we get this value 11.547. So to compare with the result that we obtained from the experiment here, so you can see this is for low speed, and then the frequency is 11.627. This waveform is generated display on the oscilloscope, and then this is the one that we get from the simulation, 11.547 and 11.627. So it's tally for me. And then we go next, we need to simulate for the medium speed. Then we set the fundamental components to 20 volt. Okay, and then again for the stop time, we need to set for the appropriate stop time, medium. We just adjust the fundamental value, and then we just click run and wait until the simulation running finish. Right, the simulation just finished. Again, we click this power GUI block, go to tools, go to FFT analysis, and then again for the fundamental frequency, we need to adjust. For the median speed is 20, and then we click display. We click display and we compare with this result that we obtained from the experiment. Okay, so the frequency that we get when we set the fundamental is 20 volt just now. Here is 19.95, almost 20, and then the frequency we get is 23.094, which is same with what we have calculated. And from the experiment result, from the experiment, we get 22.822, which is there is a minor error, but almost 23 hertz. Okay, right? This one is for medium speed, and lastly we need to simulate for the high speed. We set the fundamental component to 30 volt, and again for the stop time we need to adjust 30 here for the fundamental value, and we just click run and wait until the simulation finish. Alright, the simulation just finished, and then we just click this power GUI block again, go to tools, FFT analysis, and then we set again adjust for this fundamental frequency. For high speed we set the fundamental is 30, and then we just click display, and we compare with the result that we obtained from the experiment. Look at the here, just now we set 30 volt, 29.9 is almost 30, and then what we get is fundamental frequency is 34.64 watts, which is the same that is what we have calculated. And from the result from the experiment we get 34.765, or almost the same. So as a conclusion, what we get from the experiment, result that we get from the experiment is match and tally with the one in the simulation. That's all for me. Thank you very much.
Hai, Assalamualaikum. Hari ni kita akan buat demonstration V/F controller using SVM technique for adjustable speed drive of induction motor. So here kita dah set up, and then kita boleh buat adjustment of the fundamental. Kat sini kita ada 3 speed, kita tengok low, medium and high. And kita boleh ubah juga guna knob, and the speed will display here. And here is a start or stop button. Ni adalah untuk tujuan emergency lah. Kalau ada apa-apa kita boleh stop and start here. So kita beralih kepada demonstration. Okay, untuk sesi demonstration, pertama kita akan increase the voltage up until 75 volt. Increase slowly. Kita boleh tengok kat sana motor berjalan pada kelajuan yang maksimum. Dan kalau kita nak tengok variation kelajuan dia, kita boleh kawal mula-mula daripada low, dan boleh tengok speed motor pun low, and dekat display here kita tengok frekuensi dia pun low. And seterusnya kalau kita adjust dia medium, kita boleh tengok motor pun berjalan dalam kelajuan yang medium, and kita tengok perubahan frekuensi dia pun akan naik medium. And seterusnya kalau high, kita juga boleh tengok motor berjalan high speed and frekuensi dia akan naik high. Dan dekat sini juga untuk stop and start button, kita boleh kawal daripada sini. Contoh kalau stop, okay, motor akan stop. Alright, terima kasih.